In this example, we have a plane traveling at an airspeed of 400 kilometers per hour with a compass heading northwest. So let's kind of draw that. And it also encounters a 60 kilometer per hour wind from the north. So sketch it and find the magnitude and direction of the resultant vector. So let's draw it out. They're heading at an airspeed of 400 kilometers per hour with a compass heading northwest. So just kind of draw a little compass here. That's north, west, east, south. So it's heading northwest, it's heading up in this direction up here. So the plane vector is going to be heading northwest at 400 miles per hour, or kilometers per hour. Okay, and that means that this angle here is going to be a 45-degree angle, because northwest is halfway between north and west. It then encounters a 60 kilometer per hour wind from the north, so that means the wind would be heading south. Add a 60 kilometer per hour clip, and what we want to figure out is what is the resultant vector, and I'm going to try to color code things here a little bit. So we'll have the wind be blue. So what we're going to do is we're going to find the x and y components of each vector, add them together, and that will tell us what the resultant vector, or what the plane, is actually doing. So the wind vector is actually quite easy. There's 0 for the x component. It's not heading left or right at all. It's just going straight down to the south. And so then the y is negative 60. It's negative because it's going down. If it was going up to the north, we'd call that positive. The plane, we're going to have to do a little bit of math to figure that out. So to find the x component of the plane, this is the adjacent side, the x side is the adjacent side, the 400 is the hypotenuse side. So we're going to do cosine of 45 equals x over 400. And then I'm going to type into my calculator 400 times cosine of 45, and I get 282. Looks like I didn't give myself quite enough room here. 282.8. And that's going to be negative because it's heading left, which we'll call negative. If it was heading to the right, it'd be positive, just like we're working on a coordinate plane. And then the y direction is going up. That's the opposite. So we do sine of 45 equals x over 400. And if you remember your special right triangles, you know that the x and y are the same, so the y is going to be 282.8 as well. So our resultant vector, I'm going to do in green here, would be, if we add up the x component of the plane vector, the x component of the wind vector, and then the y component of the plane, and the y component of the wind. And that's going to give us our resultant vector. So we get negative 282.8 plus 0 is negative 282.8. And positive 282.8 plus negative 60 is 222.8. So our resultant vector is negative 282.8 and 222.8 for the x and y components of that resultant vector. So it asks us to find the magnitude and direction of that vector. That means so what this is telling me down here is that the vector is going to have an x value of negative 282.8 and a y value of positive 222.8. So this is going to be our resultant vector right here. We need to find that magnitude. So to do that, we're going to use the Pythagorean theorem. 222.8 squared plus negative 282.8 squared, and that's going to equal the magnitude squared. So I'll type this into my calculator. And when I do that, I get 360.0 for our magnitude, kilometers per hour. So that's going to be our magnitude is 360.0 kilometers per hour, and our direction, we're going to find this angle, and so I'm going to do tangent inverse of 222.8 over 282.8. And when I type that into my calculator, I get 38.2 degrees. So, we can say this direction a couple of different ways. We can say that it's 38.2 degrees north of west. So, north of west, because it's to the north, or toward the north from the west bearing. Or you could also say it is whatever 180 minus 38.2 is. Let me type that in here. I get 141.8. So you could also say it's 141.8 degrees for our direction. Either of these would work. I would imagine the most desired answer is 38.2 degrees north of west. So that is our plane problem. So on this problem it says, suppose a pilot wants to fly directly east at a ground speed of 225 miles per hour, but there's a wind from the northwest at a speed of 40 miles per hour. What airspeed and compass heading should the pilot select? So the first sentence is pretty vital that you understand what this is saying. It says, suppose a pilot wants to fly directly east at a ground speed of 225 miles per hour. So that is telling us that let me change my pen a little bit here, that this is the resultant vector. It wants to travel at a ground speed of 225 miles per hour directly east. So our answer is going to be due east at 225 miles per hour. And what we have to do is figure out what two vectors were added together to give us that resultant vector. So I know my resultant vector is going to have an x-coordinate of 225 and a y-coordinate of 0. So there are two different vectors acting together that will give us this resultant vector. One is a wind vector, and the wind vector is heading, let's see, but there's a wind from the northwest, so that means it's heading southeast at a speed of 40 miles per hour. So the wind is heading 40 miles per hour to the southeast. So that tells me that this angle here is 45 degrees. And then there is the airplane vector. And this vector is going to have to go something like this, because it's got to negate the downward force of the wind so that we can go due east, and it's got to be traveling to the right so that we can get up to 225 miles per hour. So what we need to do is figure out what are the x and y components of this airplane vector, and the way we're going to do that is by solving this equation with our wind vector plus the airplane vector is going to equal this resultant vector. So we're going to basically have to work backward on this one. So let's figure out what the x and y components are of the wind vector. And to do that, we're going to do cosine of 45 degrees equals the x value over 40. And when I type that into my calculator, cosine of 45 times 40, and I get 28.28. So we'll say 28.3. And then the y value is also going to be 28.3, because it's a 45, 45, 90 triangle. It's going to be negative 28.3. Because it's heading down in the southern direction, so that's why it'd be negative. So, I know that if I take this 28.3 and I add in the x component of the airplane, I should get 225. So let's write out that equation here. We've got 28.3 plus something will give us 225. So that's a fourth grade math problem to solve here. We're going to subtract 28.3 from both sides. And when I do that, that tells me that the x coordinate of our vector is going to be 197.7. So 197.7. Oops, sorry, I did my math wrong. Not 197.7. It's 196.7. See if I can erase that. I can't. 196.7. Sorry about that. And then I know that if I take negative 20, so I'm going to now look at the y values. So if I take negative 28.3 plus whatever this is, I need to get 0. So negative 28.3 plus, we'll say question mark again, equals 0. So if I add 28.3 to both sides, that tells me that it should have had 28.3 miles per hour in the northern direction. So I have my magnitude, or I have my x and y components of our airplane vector. It asks us what airspeed and compass heading should that be. So it's asking for magnitude and direction. So I need a little bit of room to figure this out, so I'm going to give myself some room here. And I have a vector. I'll redraw the airplane vector. It's going to look something like this. And I know the x value is 196.7, and the y value is 28.3. So if I want to figure out the magnitude, I'm going to do the Pythagorean theorem. 196.7 squared plus 28.3 squared. And that equals c squared, so I square rooted both sides, to kind of eliminate a step. So let me plug this in my calculator. And when I do that, I get 198.7 for my magnitude, and that would be in miles per hour. So I've got my magnitude, 198.7 miles per hour. Now I need to figure out my angle, theta. So to do that, I'm going to do tangent inverse of 28.3 over 196.7. And I'll type that in my calculator. And when I do that, I get a theta value of 8.2 degrees. So I would say 8.2 degrees north of east. And there we have it. We have our airspeed, magnitude, and compass heading, 8.2 degrees north of east.